Good evening everyone, class 12. So this lecture is going for you and we are going to discuss, obviously, I will teach you physics and current electricity chapter was going on, and students, we are going to discuss about effect of temperature on resistivity. तो आज हम बात करेंगे कि टेम्परेचर का क्या इफेक्ट पड़ता है रेजिस्टिविटी का. What is the effect of temperature on resistivity? This is what we are going to discuss. Okay. So students, we will consider so many materials and we will discuss it separately for all. So let us begin with conductor. First, conductor. What will be the effect of temperature if you are increasing the temperature? Then what will be the effect of increasing the temperature on resistivity? So students, I will explain you step by step. Once you increase the temperature, okay, if you increase the temperature, I will make a flow chart for you. Increase temperature. When you will increase the temperature, then there is no doubt that the electrons which were getting the energy, the thermal energy, the velocity they were acquiring by getting this thermal energy. And when you will increase the temperature, the thermal energy will increase. Okay, so increase in temperature will cause increase in thermal energy. And when this thermal energy will increase, because of increment in the thermal energy, the velocity of electrons will increase. Now students, if thermal energy is increased, the thermal velocity, because electrons are getting the energy from this thermal energy. So as soon you will increase the temperature, thermal energy will increase, and because of this, the electrons will acquire a very high velocity. So students, you can imagine the picture. Earlier, suppose I have drawn a conductor and electrons, okay, the electrons were moving like this, okay, and we can show it actually. Now, once they acquire a very high velocity, the collisions between them will increase or decrease? Obviously, the number of collisions per unit time will increase. Now, because they have a very high velocity. So, one electron, earlier it was traveling with a very slow speed and going certain distance and then colliding to other. Now, what will happen? The electron is having a very high velocity, so it will travel little and it will collide with other. It will travel little and collide with other, collide with other, collide with other, and so on. So, the number of collisions per unit time for one electron will increase a lot, and this will result in the increase in collisions. Okay, the increase in collisions. Now students, if collisions will increase, then the relaxation time, what about the relaxation time? Obviously the time gap between two successive collisions is the relaxation time. This is the time actually when the electron travels. So that relaxation time will decrease. So relaxation time will decrease. Now students, because this relaxation time will decrease, collisions will increase, and because of decrement in the relaxation time, there will be a surely increase in the resistance. So once you increase the temperature for a conductor, the resistance will increase. So this is what you have to remember. Okay. Now students, we are going to study about thermal coefficient of resistivity. So conductors, I think so that the doubt is clear for you. So the new topic is thermal coefficient of resistivity. This is denoted by alpha. Might be you are thinking sir was teaching us the effect of temperature on resistivity, and now sir is teaching us thermal coefficient of resistivity. So I will tell you that these are interlinked. For understanding the behavior of various material, we should be aware about one particular terminology, that is thermal coefficient of resistivity, denoted by alpha. So for understanding this, consider a material, consider a conductor or any material, and initial resistance offered by that is Rho, that is initial resistance means original resistance, offered by it is R0, okay, and we increase the temperature, so increment is the change in temperature, so we will denote it by delta T. So suppose we increase the temperature, as delta T, and because of this increment in the temperature, because you are increasing the temperature, suppose the final resistance, there will be a change in the value of resistance as you have changed the temperature. So suppose the final resistance becomes R. So what is the increase in resistance? What is the increase in resistance? So our answer is, as finally our increased resistance is R, so increase in resistance will be R minus R, final resistance minus previous one. So when we increase the temperature, by delta T amount, then what is the increase in resistance? R minus R. Or we can say for R0 resistance, the increase is R minus R0. For R0 resistance, the increase is R minus R0. Then for unit resistance, for one resistance, what will be the increment? That will be R minus R0 upon R0. Now students, in the similar way, when we increase the temperature by delta T amount, this unit resistance increases R minus R0 upon R0. And suppose we increase the resistance by we increase the temperature by 1 degree. If you will increase the temperature by 1 degree, then this delta T will be divided. So this will be R minus R0 upon R0 delta T. And this is known as coefficient of thermal resistivity. Okay, and this is denoted by alpha. So alpha is equal to R minus R0 upon R0 delta T. So how to actually define this? Thermal coefficient of resistivity, we will define it as this alpha is the increase in resistance. This alpha is the increase in resistance. In the numerator, there is increase in resistance. When the specific condition is when the original resistance is unit, because this should be 1. If R0 will be equal to 1 and delta T will be equal to 1, then alpha will be equal to R minus R. By applying this specific condition, you can define this alpha. So you can say coefficient of thermal resistivity is defined as the increase in resistance for a conductor having unit ohm resistance and the increase in temperature by 1 degree Celsius. So this is how we define it. And what is the use of it? You will further study and you will come to know. And now from this equation, as we have got the equation, alpha is equal to R minus R0 upon R0 delta T. So students, once we solve this equation, there will be cross multiply. So R minus R0 will be how much? R minus R0 will be equal to alpha R0 delta T. And what will be the value of R? R will be R0 plus alpha R0 delta T. Now, if you take this R0 common, so new resistance will be how much? 1 plus alpha delta T. 1 plus alpha delta T. Now, if you use mathematics and your sense, then you will come to know that the new resistance is equal to 1 plus alpha delta T. R0 into 1 plus alpha delta T. Now, what is the significance of this? The significance of this equation is if the value of alpha for a material will be very high. If the value of alpha will be high, then the new resistance will be very high. If value of alpha is low for a material, then the change in resistance means the new resistance is getting low. So alpha is a factor which decides that whether a material is going to increase its resistivity by a great amount or by a very less amount. So this is the use of thermal coefficient of resistivity denoted by alpha. I hope you understood this, and this will help you for studying the new terminologies which we are going to discuss on today's lecture. Okay, so let me erase this all. Topic same is going on, effect of temperature on resistivity. So don't worry about that. Effect of temperature on resistivity. So students, let us discuss about another things. Like we can discuss it for alloys. What are alloys? And what will be the condition for alloy? The resistance will increase or decrease? You should imagine about the picture. Once you are increasing the temperature, okay, so what is the new resistance? R is equal to R naught 1 plus alpha delta T. So let me tell you one thing. For alloy, the value of alpha is very less. The value of alpha is very less. So there will be a less effect of changing the value of temperature for alloys. So this will be less affected comparatively as the value of alpha offered by these material alloys is getting less. Now, what is the effect on semiconductor? On temperature. Suppose we are increasing the temperature, okay, and because of increment in the temperature, what is the effect on resistivity for semiconductor materials? So students, imagine if you remember one equation I already have explained you, rho is equal to m upon n e square tau. Resistivity is equal to m upon n e square tau. For a semiconductor, we can consider the example, say silicon, germanium. These both are semiconductor materials. Okay, their conductivity is between the conductors and the insulators. So resistivity formula is rho is equal to m upon n square tau. So let me tell you one thing. Once you increase the temperature, then from the atom of semiconductors, the electrons, more and more number of electrons will getting free, because they are getting the thermal energy, and because of increase in the thermal energy, they will acquire an energy, and because of that energy, the electrons will be ejected out from their nucleus, from their atom. And when electrons will be ejected out, then what is n here? N is number of free electrons, n is the free electron. And students, now when this free electrons will increase, obviously these free electrons are increasing because more and more electrons